Interfacing technology. First is direct machine coupling with the grid. So which are the sources we can use here? Sources that can be directly coupled to the grid are wind power, small hydro power, and some combined heat power. So it is more efficient to transfer mechanical power into electrical power through direct machine coupling to the grid without any intermediate stages. Here you can observe the wind power, gearbox, induction generator, reactive power compensation, line filter, transformer, and it is grid. So here the choice of the type of the machine depends on the nature of the mechanical power supplied. So the choice of the type of the machine, it depends upon the what? It depends upon the mechanical power supplied. So here constant mechanical power means it can be constant rotating speed, so we can use a synchronous machines. Strongly variable power means it is a induction machine. So here permanent magnet synchronous machines are utilized for slow rotation speed turbines. So linear synchronous machines is used to transfer the vibrational energy into electrical energy. So for which source, which machine we need to use? Okay, for constant mechanical power we need to use a synchronous machines with the constant rotating speed, and here strongly variable power, in that case we can use a induction machines. So if it is a slow rotational speed turbine, okay, slow rotational speed turbine, then we can use a permanent magnet synchronous machines. Okay, so it is a required to transfer vibrational energy. Okay, for in that case linear synchronous machines we can use. Slow rotational speed, permanent magnet, vibrational means linear synchronous machine. Okay, vibrational, linear, slow rotation, permanent. So here variable, induction, and constant synchronous machines. Synchronous machine is used to interface small hydropower and some CHP, that is combined heat power, where mechanical power is controlled to the controlling the speed of the shaft. So here mechanical power is controlled through what? Controlled to the controlling the speed of the shaft. Synchronous generator can be a source of both the active and reactive power to the electrical system. So it will generate and it will absorb, okay, reactive power. So here induction machine is used to interface variable speed energy sources with the grid. The clear example of this is wind energy sources. We have already seen the figure, but they generally suffer from the disadvantage of drawing reactive power from the system and also from drawing high starting current that may cause local flicker. So in the figure we have observed that we have used a induction generator. So they generally suffer from the disadvantage. It will draw the reactive power. Induction generator means it will absorb the reactive power, okay, from the system. So it will also draw high starting currents. It will draw high starting currents that will cause a local flicker, okay. Induction machines for direct connection of DGs are restricted because of their excitation requires reactive power supplied basically from the grid. So why they restrict induction machines means because their excitation requires reactive power, okay, which need to be supplied from the grid. Okay, that's why they restrict the induction machines for direct connections of DG. So induction generators are like induction motors, requires no synchronizing equipment. Here induction generators are like, it is like induction motors, it does not require it is requiring no synchronizing equipment. They are less costly than synchronous generator. If we compare cost wise, induction generators are less cost, that is they are less costly than synchronous generator, and the protection required is only over and under voltage and frequency relaying. Okay, the protection is required for wind and low head of river turbines. The rotational speed is slow, okay. So in that case, large multiple pole generator, example permanent magnet synchronous generator, we have already said that. Okay, slow rotational speed, in that case we can use a permanent magnet. So for wind and low head of river turbines, in that case we can use a PMSD, that is permanent magnet synchronous generator.